Today we're going to be solving polynomial rational inequalities. We'll start with the polynomial ones. It tells us to solve polynomial inequalities. You can use the fact that a polynomial can change signs only at its zeros. So the first thing we will want to do is find all the real zeros of the polynomial and arrange the zeros in increasing order, smallest to largest. These zeros are the critical numbers of the polynomial, and then we check the intervals between each critical number to find the solutions. What that means right there, if you remember a polynomial, it looks like this. It only changes the sign from positive to negative when it drops under a zero, and then from negative to positive when it goes above that zero. So these zeros right here are really important of the polynomial. That's what we're going to use as our critical points. We usually find those by factoring. So that's how we'll start this. X squared minus 5x minus 14 is less than 0. I would factor, which hopefully you're getting really good at. And then I find my roots. And so the roots are at 7 and negative 2. So I'm going to go ahead and draw a number line here with negative 2 and 7. Those are my critical points. Those are the 2 points where it is equal to 0. Now this does not have an equal sign. So this would be an open circle and this would be an open circle. If there was an equal sign there, then they would be closed circles because that's the point where they are set on 0. So now we need to figure out at where are our solutions, whether they're in this interval, this one, or this one. We want the values that are less than 0. So we want to think about the different points here. You don't really care what the value itself is, but if you think about the values that are less than 0 are negative. The ones that are bigger than 0 are positive. So I want to know where there's negative values. So if I plugged in 0, for example, here, because between negative 2 and 7, there's a 0, that would give me a negative times a positive. And a negative times a positive is a negative. So these values are all going to be negative because we said they're either all positive or all negative. Now I plug in something bigger than 7. So for example, 10, that would give me a positive times a positive, which is a positive. On this side, if I do negative 10, that would give me a negative times a negative, which is also a positive. The values that are less than 0 are negative values. So this is where our solutions are found. These are where the negative values are. So from negative 2 to 7 would be the interval of our solutions. Since those are open circles, they're going to be parentheses. If they were closed circles, they would be a bracket. So from negative 2 to 7 is our solutions. We're going to do the same thing here. If you want to pause and try it, you can. So we factor. We find our roots. In this case, at 5 and 1, it is equal to 0. So this polynomial is 0 at 5 and 1 because that's where our roots are. That's where it has a value of 0. This does have an equal sign. So we want those values that make it 0. So that's going to be a closed circle there. Now we check our intervals. Between 1 and 5, we can find 3. If I plugged in 3 here, this would be negative times a positive, which is a negative. If I picked a value greater than 5, so for example, 10, I plug that in here, and that gives me a positive times a positive, which is a positive. And if I plugged in 0 here, that would give me a negative times a negative, which is a positive. Now we are looking for the values that are greater than or equal to 0. The values that are greater than or equal to 0 are the positive ones. So our solutions would be found here and here. We write that as negative infinity to 1. We would use a bracket for that because we are including the 1. We include the 5 and it goes to infinity. There's a couple more for you to try here. So go ahead and try some, pause the video, and then I'll show you guys the answers after that. All right, so check your work. You should have gotten -4 to -3 and -8 to 1. On these next two, again, you would want to factor. I got my two roots, and so I've got one at 4 and one at 7. Open circles since there's no equal sign, and we want to go ahead and test some points. And so 0 would be over here on the left. I plug that one in first, and I get a negative times a negative is a positive. 5 is here in the middle. That would give me a negative times a positive, which is a negative. And then when we look at our last one, 10 would give me a positive and a positive, which is a positive. We're looking for the values that are bigger than 0. Those are positive values. Negative values are smaller than 0. Positive values are bigger than 0. So these are our solutions. We would write that as negative infinity to 4 because it's coming from the left-hand side up to this point right here. That's a parenthesis since we're not including that point. Then we pick back up at 7 and we go to infinity. So that is our solution set there. That's where all of the values bigger than 0 are going to be found. Go ahead and do this one too, since it's got one of those factoring ones that are a little bit harder. So you would want to use a box or slide and divide or some other method of factoring. So I'm going to go ahead and slide and divide. So I slide my 3 to the end. That gives us -24. I factor like normal. And so I get x plus 12, x minus 2. And then we would divide by the 3. If it divides evenly, we leave it like that. If it does not divide evenly, that is our coefficient. This is exactly the same thing. It's just a little bit harder to get this root. Remember that you're going to go ahead and set that equal to 0. We add the 2 to get it to the other side and divide by 3. That's the only difference, is getting that root that's a little bit harder. This one here, we already know that's -4 because that makes it 0. Just because it's a fraction though doesn't change anything. We can put it in the number line exactly the way we see it. -4 and 2/3. It has no equal sign, so those are open circles. And we would not want to pick some fractions. You can just still pick any number between -4 and 2/3. It does not have to be a fraction. So if I pick 0 and I plug that in here, that would give me a negative and a positive, which is a negative. If I plugged in -10, that would give me a negative and a negative, which is a positive. And then if I plugged in +10, that would give me a positive and a positive. And so our values that are bigger than 10 occurred on the left and the right. And so our interval would say -infinity to -4. Again, in parentheses, since they're not closed circles, and then it would pick up at 2/3 and go to infinity. So just because it's a fraction doesn't change anything. Don't be scared by it. All right, for this last one, it is x³ minus 3x squared. I can factor out an x squared out of there, and I'm left with x minus 3. That gives me still two values to put on my line for the critical points. I've got a point at 0 because that's what makes this 0. And I've got a point at 3 because that's what makes that one 0. So I've got two open circles there. On this one, I'm going to make you think about it as a graph because maybe that will help you guys out in understanding what that is. Remember when we graphed, we said 0 here and 3 was here. And we said if it had an exponent of 2, it was tangent at that point. And if it had an exponent of 1, it was crossing at that point. And this is positive and odd. So it starts at the bottom and it's going to be tangent at 0. And then it's going to cross at 3. So that's what this polynomial looks like here. We're looking for the values that are greater than 0. Well, the values that are greater than 0 are going to occur right here. So that's going to be all of my points bigger than 3. So this one's kind of a special case there. Right here, neither one of those would be because they are below my 0. So I just showed it to you on a graph. We'll go ahead and plug a point in. If I plugged in 1 here, that would be positive times a negative, which is a negative. And if I plugged in -5, that would give me a positive times a negative, which is a negative. So in this case, these were negative, and these were positive. Most of the time they split this way, but there's a special case for you to see. All right, we're going to switch off now to rational inequalities, and they work similar to our polynomials. We need to find our critical points. For rational inequalities, the critical points are the values that create an undefined value in our equation. So what makes that denominator undefined? And our zeros, just like with polynomials. So if we consider this first equation right here, the value that would make it undefined is -2. -2 plus 2 makes that denominator 0. So -2 is my undefined value. The value that would give me a 0, remember that's what makes my numerator 0. 5 minus 5 would make that 0. So there's our 0 value. Now we'll go ahead and practice some. So we need to make a number line here for our critical points. The first critical point is whatever makes that denominator 0. So 2 minus 2 makes it 0. So that's one of my critical points, the vertical asymptote. And then I'm looking for the 0. And that's whatever makes my numerator 0. So that's -3. That's that x-intercept. So our x-intercept is whatever makes our numerator 0. Our vertical asymptote is whatever makes the denominator 0. So now we've got -3 and 2. Rational inequalities are kind of cool in the fact that one can be an open circle and the other one can be a closed circle. The vertical asymptote is the point that we jump over. So that's always going to be an open circle. It's undefined there. So there's no way you can have a point that's equal to it. So that's what this one is always going to be an open circle. The other one is when it's equal to 0. Well, here there's no equal sign. So this one's going to be an open circle. Now we're ready to do the same thing we did with the polynomials. See where it is positive or negative. We're looking for the ones that are greater than 0. So we would be looking for our positive ones. But we'll start looking at all of them. So between -3 and 2 comes 0. If I plugged in 0 here, we would get a positive divided by a negative, which is a negative. If I tried 5, I would plug 5 in here and I would get a positive over a positive, which is a positive. If I plugged in -5 from this side, and remember, you can pick any point to the left of -3. So it could be -4, -5, -6, any number. I'm just picking the ones that I think are easier. So -5, if I plug that in here, that is going to give me a negative value over a negative value, which is a positive value. Since we're looking for what's bigger than 0 and the positive numbers are bigger than 0, then these are my solution intervals right here, the positive ones. And so we write that out just like we did with polynomials, from -infinity to -3, parentheses on the -3 since it's an open circle, and then it picks back up at 2 and goes to infinity. All right, we'll try another one here. Vertical asymptote at x equals 4, because that's what makes my denominator 0. Our 0, or x-intercept, is whatever makes that numerator 0, which is 0. We set up our little line at 0 and 4. 4 is always going to have an open circle. Now at 0, that's when this left side is equal to 0. And this does have an equal sign, so we would want a closed circle at 0. So this one is closed, this one's open because this is undefined at that point. Between 0 and 4, we can go with 1. If I plugged in 1 here, that would be positive over negative, which is a negative. If I plugged in 10, that would give me a positive over a positive. If I plugged in -10, that would give me a negative over a negative, which is a positive. We're looking for the values that are less than 0. And so that's our negative values. In this case, I would want the 0 with a bracket and the 4 with a parentheses. We are not including the 4, we are including the 0. All right, let's go a little bit harder with these. In this case here, we can factor that bottom. And so we get x minus 7 over x plus 3, x minus 3. Hopefully you're recognizing that difference of squares. That's an important pattern we told you to make sure you knew. So in this case, our vertical asymptote is at x equals negative 3, x equals 3. You're probably wondering, which one do I use? You use both of them. And then for our 0 or our root or x-intercept, however you want to call it, it's whatever makes my numerator 0, which in this case is 7. So we're going to go ahead and make our line here. I've got a point at negative 3, I've got a point at 3, and I've got a point at 7. At negative 3 and 3, those are open circles. And at 7, that's a closed circle, since that's where it equals 7. Now we check our points in each section. I always like to check 0. I think that one's the easiest. If I plug in 0 there, that is a negative over a negative, which is a positive. Between 3 and 7, that would be 5. If I plug in 5 there, that's a negative, positive, sorry. Negative over positive times a positive, so that is a negative. If I plugged in 10, that would be a positive, positive, positive. If I plugged in negative 10, that would give me a negative, and a negative. We're looking for the ones that are less than or equal to 0. So in this case, we would be looking for the ones that are negative. So those are the values that are going to give us our solutions, from negative infinity to negative 3, and from 3 to 7. Don't forget to put that bracket on 7 because it is included. Go ahead and try this next one. I'll go ahead and pause the video, and you pause the video and then check your video, check your answer. All right, check your work. That one had 2 intervals, and this one had 2 brackets. So the negative 2 and the 2, you did want the closed circle because that's where it's equal to 0. And then the 6, which is our negative 6, is our vertical asymptote. We would want that one as an open circle. All right, on the last 2, I'm not going to work them here, but I do want to show you what that looks like when it's written out. It says the weekly income in hundreds for the 10th week is given by this equation. When will the S be 7 or more? So I would plug in 7 for my S. And get this equation right here. Now I need to make this an inequality. It says, when will it be 7 or more? So I want it to be more than 7, so it needs to be on the closed side of that inequality. It does say it can be 7, so then I would also want the equal sign. And then you would solve this one just like you do the others. All right, for our last one here, it says the average daily cost in dollars for manufacturing computers is given by this equation, where X is the number of computers manufactured. When will the average daily cost be less than $100? That's the way it is with rationals. Since they're all splitting this price of $1,400, then the price is getting smaller and smaller. But it wants to know when the average daily cost is less than 100. So we would put the cost of 100 in for C of X. And then we have our equation 900X minus 1,400 over X squared. We're looking for our inequality here, and we want it to be less than 100. That means the 100 has to be the bigger number. So it's going to be on the open side of that inequality. So that's setting them up. And again, you would solve those just like the ones you did at top. We're going to focus on just the solving.